Homework number 27. For question number 1, you're asked which one of the following 4 options is equivalent to 2 to the negative 5th power times 2 to the 8th power. So anytime you are multiplying like bases, in this case, the base is 2, then we know that we're going to keep the base the same, but we're going to add these exponents together. Negative 5 plus 8 is 3. So we're looking for an answer that will also be 2 to the 3rd power. For option A, it is a quotient of like bases. And when you divide like bases, you keep the base the same, but you subtract the powers. So we're going to subtract this bottom power, and we're going to get 2 minus negative 1, also known as 2 to the 3rd. For option B, we have a power raised to a power. And when we do that, we multiply, which is going to give us 2 to the negative 3rd. Letter C is another quotient of like bases, so we're going to subtract the powers, but negative 2 minus negative 1 is 2 to the negative 1st power. And again, for option D, we're going to multiply, and we're going to get 2 to the negative 3 power. So the only one that matches the original question is option A. So that would be the correct answer for this problem. Question number 2 asks you to solve for x when x to the 3rd power is equal to 64. And the only way to remove a power of 3 is to use a root with the same index. So the cube root is the inverse of x to the 3rd power. And what you do to the left side, you must also do to the right side. So we're looking for some number that when times by itself 3 times, we're going to get 64. And we can use our calculator to do this math for us. Now there's a difference between the square root button on your calculator and the cube root button on your calculator. So make sure you're using the right function. So a cube root button requires you to press the number 3 before you activate the second key. And for us, that 3rd root power will be above the exponent sign typically. So let's open our calculator and take a look. So when I turn my calculator on, I have to press the number 3 first, then I can press that cube root button, which for most of you is above this arrow key. On this fancy calculator, it's actually in a different menu here. The math button, and it's right here. It's option number 4. But for the others of you, you'll have to press the second button and then the exponent key. And we want to find the cube root of 64, and that's 4. So we're able to find the correct answer. Question number 3 is a combination of exponent rules. So with our base here, 5 to the negative 2 power raised up to the power 5, we're going to multiply and get 5 to the negative 10th. Now we can continue on with the problem of multiplying by 5 to the 4th. Again, when you multiply like bases, you keep the base the same and you add the powers together, which will give us negative 6. Now you can never end a problem when your power is still negative. So what you do to make it positive is you take the reciprocal and make the power positive. And that would match option C. Question number 4 asks you to find the cube root again. But this time, it's not multiple choice. It's a show your work question. So you can either enter a drawing by clicking this button here and writing x to the 3rd power equals 125. And it might be messy, but that's okay. The grader will understand. And now, how do we get rid of a cube? It's by using a cube root. And don't forget to show your work on both sides. Then you're going to pick up your calculator and you're going to compute. So this is one way that you can show your work. And when you're ready to insert it, you click Add Drawing. Another way that you could show your work is by using some of these features here when you're typing. So if we know that we want to take the cube root, we might want to use this character here, where it gives us a field where we can type a 3 outside, and then underneath we want x to the power of 3. So I'm actually going to use the exponent button, which is right over here. So first I use this cube root button, and then I'm going to use this power button. That gives me x and the power of 3. And now I can arrow to the right outside of that character and press equals. And again, use that cube root key over here to type the index 3 and then to type the 125 underneath. Now I can press enter and just type with my regular keypad that x is equal to 5. That's another way that you can answer this question. This one asks you, what is the rate of change of these 2 points? Now you may remember that when you have 2 points, you call the first one x1, y1, and the second one x2, y2. And maybe you also remember the formula. The rate of change is y2 minus y1 over x2 minus x1. Now make sure you're erasing and replacing with the correct values. So y2 is 3, and y1 is 7. And the minus sign is from the formula. Now we're going to do the same thing with x2 and x1. And x2 is 3, and x1 is negative 3. Oops, we need a 3 here. And now we can compute. You can either use a calculator or you can do the math mentally. So negative 4/6 is the same as negative 2/3. But on your calculator, you could type the entire fraction like this by pressing the fraction button, and you could type 3 subtract 7 in the numerator, and then 3 subtract negative 3 in the denominator, and it will do all the reducing for you. So negative 2/3. Question number 6 asks us to identify the transformation that takes figure 1 onto figure 2. So you notice figure 1 over here, it has a feature that's kind of pointing to the left, but now it's kind of pointing to the right. So it's changed its orientation, or it has flipped over. And a flip is a reflection. And if it reflects over this axis here, then it's a reflection over the y-axis. In this example, we have pentagon P and pentagon Q, and they tell us that they're congruent. So they're asking us which of these transformations could have been used. Now we know if shapes are congruent, then that means that they are not a dilation. So we could scan through all of these options to see if any of them said dilation, and we could cross them off. So now let's take a look at how P and Q are related. Well, it definitely looks like they're facing different directions. So maybe they rotated or maybe they reflected. So it looks like we have a 180-degree rotation. On this one we have a translation 4 to the left and then a reflection over the x-axis. So let's see. If we translate 4 to the left, 1, 2, 3, 4, and then reflect over the x-axis, we'll probably be pointing like that. So that cannot be right. So B is out. And let's see, A. On 180 degrees clockwise rotation. Well, that means it would turn this way and then it will turn that way. So it's possible, but let's take a look. I know if 180-degree rotation of the point 3, 2 means that everybody changes signs. Negative 3, negative 2. So negative 3, negative 2, there is no point there. So that means that this one is out. So A and B are out. Now we're going to have to look at C and D. So a reflection over Y and then a translation 7 units down. Let's see. A reflection over Y would bring me this way. And so I would probably be pointing like this, right? Whoops. Probably be pointing like this. And then a translation 7 units down. Is that what it said? Reflection over y, and a translation 7 units down. So let's find this point. A reflection over y would take this point to negative 3, 2, and then 7 units down would take the point to negative 3, negative 5. So negative 3, negative 5 would be here. That's a match. Let's try one more. 1, 5, when reflected over the, I think I read that wrong. That's reflecting over the y-axis. Let's see. This says reflecting over the y-axis. Okay, yep, that's it. So let's finish it. Let's double check that second point. 1, 5, reflecting over the y-axis is negative 1, 5, and then 7 units down is negative 1, negative 2. Negative 1, negative 2. Yep, that's a match. So it looks like we have found our option. A sequence of transformations was applied to an equilateral triangle. The transformations were rotations, reflections, and translations. So what statement is true? Well, we did not use a dilation, so that means they are definitely congruent. So every side and every angle will be the same as the original. So it must be an equilateral triangle, yes, and it must have the same side lengths, yes. This is looking good. B, it must be an equilateral triangle, yes, but the side lengths may differ, no. It can be a different triangle, no. It can be an obtuse triangle, no. So it has to be exactly the same shape, exactly the same size, because we used all rigid motions. So that means that A would be the right answer. In this question, they tell you that ABCD was rotated 90 degrees clockwise to form WXYZ. So which statement is true? Well, the order of these letters has to match the order of the letters in the next figure. So WXYZ. A would match to W, B would match to X, C would match to Y, and D would match to Z. So if this option says D and A go together, then Z and W would go together. And that's not what it says. So DC means we go from last to third, and then X to Y, totally different move. So those are not the same order. B to C and Y to Z, yep, these two and these two are a match. But the order is different. If I go from B to C and I go from Y to Z, they're not moving in the same direction. But for the last one, if I go from A to B and W to X, they're a perfect match. So that makes D the right answer. Question number 10. Triangle ABC is dilated by a factor of 1/2, centered at the origin. What will the resulting figure be? So A prime, B prime, C prime will have the same points, but they will have been multiplied by 1/2. So I'm going to time each of these by 1/2, giving me the point 3, 2, or option A. For question 11, they want you to use the point 2, negative 3, and using the list of transformations below, explain how we get to the final place of A prime. So you can either open a drawing and draw what happens to A, or you can use the typing feature. So since they ask you to explain, I'm going to type what happens when the point 2, negative 3 is rotated 180 degrees, both coordinates change signs, giving me negative 2, positive 3. When negative 2, positive 3 is reflected over the x-axis, the y-coordinate, and I can abbreviate it here, changes signs, giving me negative 2, negative 3. When negative 2, negative 3 is reflected over, I have a typo there, over the y-axis, which is the final move, the x-coordinate changes signs. Why am I keep typing that E? Changes signs, giving me A prime, which is positive 2, negative 3. So that's all you need to type. If you wanted to do a drawing, you could use your finger to show, like this, and then you could say 180 degree rotate is negative 2, positive 3. You don't have to write the positive sign, but then you could say reflect over x, and you can give it, and reflects over y, etc. So you could use the drawing tool as well. Question number 12 asks us what the new coordinate of B will be after we rotate 90 degrees clockwise. 90 degrees clockwise means we swap the points and draw an arrow clockwise and change the sign. So the point will be 1, 4. Question 13 says that triangle P undergoes a sequence of transformations. Which one will make it similar but not congruent? The only thing that does that is a dilation. So we're going to scan for the one that has a dilation. In order to find the value of x here, you need to know that all of the angles in a triangle add up to 180 degrees. So in this case, that means 30 plus 3x minus 9 plus 24 is going to equal 180. So I'm going to combine like terms. 30 minus 9 is 21, and 21 plus 24 is 45. And now I'm going to solve this equation by subtracting 45 from both sides, giving me 3x is equal to 135, and dividing both sides by 3, and getting x is equal to 45. In this example, they're asking you to find the value of n by knowing that these two angles are alternate interior angles, and alternate interior angles are equal. So 3n plus 16 is equal to 5n plus 4. So I'm going to subtract 3n from both sides. And I'm going to subtract 4 to both sides, giving me 12 equals 2n. And when I divide both sides by 2, I get n is equal to 6. Question 16 is also using parallel lines. These are also congruent for a different reason. They're corresponding, but they are equal to each other. So 13x plus 6 equals 11x plus 30. I'm going to subtract 11x from both sides. giving me 2x plus 6 equals 30. And then I'm going to subtract 6 from both sides, giving me 2x equals 24. And finally, dividing both sides by 2, giving me x is equal to 12. Which list of numbers could represent the lengths of a right triangle? So a right triangle has to comply with the Pythagorean theorem, that a squared plus b squared has to be equal to c squared. So we're going to test, is 5 squared plus 10 squared equal to 13 squared? Well, is 25 plus 100 equal to 169? No. So that means A is out. Let's try B. Is 5 squared plus 12 squared equal to 17 squared? Is 25 plus 144 equal to, I needed a calculator for 17 squared, and this will give us 169 equals 289. That is not true. So that means this one is out. Now we're going to try C. 10 squared plus 24 squared equals 26 squared. So is 100 plus 576 equal to 676? And that one is yes. Question number 18 asks you which one is the best fit of the scatter plot. And a scatter plot has to have a line that goes through the middle of the data. So you notice here I have a line, but all of the data points are below it. Over here I have a line that's going in a totally different direction of the data. Same with B. But with option A, the points do go very close to the line. Some are above, and some are below, and some are directly on it. So that makes A the best choice. Question 19 asks us to describe what's happening if, on a scatter plot, the y values are going down, decreasing, as the x values are going up. So as the x values are going up, the y values are going down. So what does that look like to you? It looks like it has a negative slope. In this example, they're asking you what type of association or correlation the scatter plot is showing us. And if you look carefully, the scatter plot is all over the place. I can't say if it's going up or down or even sideways. So we say that when it's scattered all around like that, it has no association. Here's another scatter plot. Same question. Which statement best describes the data? Well, let's take a look at the direction of the data. My prediction line, or line of best fit, is moving downwards. So I'm looking to say that it has a negative correlation. I'm also looking to say that they kind of follow along this straight line path. So it definitely has a negative association, and it's definitely linear. It's not positive, and it's not curved. So all of these are out. Number 22 asks us to find the volume. Now, in order to find the volume, you have to identify this shape. And this shape is a cone. And a cone uses this volume formula, which will be provided to you on the reference sheet. All you need to do is identify the radius and the height. So on our calculator, we're simply going to type 1/3 times pi times the radius, whatever that number is squared, times the height. So I'm going to pick up my calculator now. I'm going to type the fraction, 1/3. Then I'm going to type the pi button. Then I'm going to type parentheses 6 squared. Whoops. This other parentheses in here. Parentheses 6 parentheses squared. And then we need times 11. And when I press enter, I get 414.69. But they're asking us to round to the nearest cubic centimeter, or whole number. So that means it's 415. Question 23 is again using our exponent rules, and we have two problems here. Multiplying like bases, but we also have a quotient of like bases. So I'm going to perform this operation first. I'm going to leave my 2 squared, but now I have 2 to the first, subtract 1 from 4 and 4. So 1 minus the bottom exponent gives me negative 3. And now, when I multiply like bases, I keep the base the same and add the powers together. So 2 to the negative 2 power. In this one, they're asking you to write the volume formula for a sphere, and that will be provided for you on the reference sheet as well. It's 4/3 pi times r cubed, or r squared times h. But r is the same as h, so that's why it can be r cubed. So if they're telling you that a sphere has a radius of 4 inches, then that means that the volume formula for a sphere would be this. And if they're telling you that a cone has a radius of 3 inches and a height of 8, then we would use the volume formula for a cone, pi r squared h, by erasing and replacing the r and the h with the right numbers. And in this case, the r is 3 and the h is 11. The h is 8. So if they're asking you to find the difference, then we need this volume formula first, which is why these look the way they do, and we need the cone second. So let's double check these numbers. You should have a 4 to the 3rd power inside here. So that means that these are wrong. And then we need a 3 with the 2nd power in here. So that means that this one is wrong, leaving us with this only option. Okay, last question. Which equation describes a linear function? Well, a linear function cannot have any powers, cannot have any powers, cannot have any powers. So that must mean B is the right answer. All right, solving equations. We're going to distribute here to get 2.5 times x and 2.5 times 5. And I used my calculator to compute 2.5 times 5, and I got 12.5. The right side of the equation stays the same. And now it's time to use an inverse property to get my x's together. So subtract 2.5x, giving me 12.5 equals 5x minus 0.5, and then add 0.5 to both sides, giving me 13 is equal to 5x. And when I divide both sides by 5, I'm going to get 2 3/5, or 2.6. Question 27 asks you to classify each number as either rational or irrational. Then it says to be sure to include how you know if a number is rational. So why don't we just make a list of all the rational numbers? So the rational numbers are the square root of 49. Click in here so I can type it. Then I'll put a comma. And I'm going to put 1 point, and I'm going to use this button here to put that repeating bar, 3. That is rational. And 7/2 is a ratio, so that is the fraction button here, 7/2. And then the final one, 1.234, are all rational because and you have two options here. You can either say the textbook definition, which is they can be written as the ratio of two integers. That's it. So if these guys are rational, then that makes these numbers square root of 32, or the only one, right? So rational, rational, irrational, rational, rational. Why is it rational? Because it can be written as the ratio of two integers. Short and sweet. The steps a student took to solve an equation are shown below. What error did the student make, and what is the correct value of x? All right, well, I think I'm going to start by writing down the equation using the fraction button, 3/4, then using parentheses and typing negative 8x plus 20, then arrowing out, typing equals negative 8, parentheses, negative x minus 3, then pressing enter, and I'm going to use my calculator to compute here, and I'm going to use the fraction button 3/4. I'm going to multiply it by negative 8, so that's negative 6, and then again 3/4, but this time I'm going to multiply it by 20. So it looks like I get negative 6 and 15. So I'm going to get negative 6x plus 15 equals, now I have a negative 8 times a negative x, so that's going to be positive 8x and a positive 24. Now I'm going to add 6x to both sides. Now I can type it if I want, space, 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 right? Or I don't have to type it at all, and I can simply type the solution, which is that 15 is equal to 14x plus 24. Now I'm going to subtract 24 from both sides. Now I can type it like this with the space, 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 or I can just write the answer, which is that 15 minus 24 is going to be 9 equals 14x. Then I'm going to divide both sides by 9, leaving me with the fraction 9 divided by 14 is equal to x. Let's see. So negative 6x plus 15, we got negative 6x plus 15 equals 8x plus 24. Okay, so we agree with step number 1. And then step number 2, we got 15 equals 2x plus 24. Oh, and we got 15 equals 14x plus 24. So we know that there's a mistake in step 2. So now, underneath my answer, we can say the student made a mistake in step 2. They wrote 2x instead of 14x because they subtracted 6x from 8x by accident, right? There we go. All right, question number 29. I think I'm going to use the writing tool this time. 8 times j minus 4, so we can write 8 times j minus 4. And let's see, equals 2 times 4j minus 16 equals 2 times 4j minus 16. I'm going to get 8j minus 32 equals 8j minus 32. Oh, I see it already. You see that? Oops, my screen's going crazy. When the left side and the right side are a perfect match, we have infinite solutions. Ooh, this is annoying. So I'm going to add my drawing, and now I'm done. All right, this question asks us to find the volume of this object. Well, the object has two shapes. It has a cone on the top So I'm going to use the cone formula, 1/3 pi r squared h, and then it has a cylinder on the bottom, which is pi r squared h only. I'm going to add them together. So let's see, I'm going to get 1/3 times pi times r. The radius of this cone is half of the bottom, that's 2, and the height of the cone is 3. And then I'm going to add to that pi times the radius of the cylinder, which again is 2, times the height of the cylinder, which is not 10 because I have 3, so the height is 7. It says to leave all the answers in terms of pi. So let's see, I'm going to get 1/3 pi times 4 times 3, which gives me 1/3 times pi times 12. And over here I'm going to get pi times 4 times 7, or pi times 28. And it looks like 1/3 of 12 is 4. So 4 pi plus 28 pi is going to give me 32 pi. And that concludes homework 27.